Hello everyone. Today's topic is about pointers. Pointers in C language. Without pointer, we even don't have any government competitive exams, even in GATE. So almost in all competitive exams, which the background of computer science and GATE exam, minimum two questions will cover from pointers of C language. It is very logical concept and also very important for the students. So what do you mean by pointer? So before go to the pointer, first we should understand about the memory. How the memory is there in the real computer, or here I could say it is like a temporary memory. So it's the memory also seems like a grid kind of structure. So there are, let us consider this is a very small area of a memory, and memory has a address for every byte. So let us consider one box is equal to one byte. Now every byte has their own address. Now there are some six, seven rows are there, and there are how many columns? We have five columns are there. So this is a small part of a memory. I am saying that this is the first byte. So this is the first byte. This is the second byte. This is the third byte. Okay. So this is the fourth byte. Like that, I am giving a numbering for the each byte. Fourth byte like that. Each byte has their own address. Address uh, will become a reference to access that corresponding byte. So let's consider this address of this memory is a something like a 2000 is the address of this corresponding first byte. If it is 2000, the next one is become a 2001 is the second byte address. Next byte address will become a 2002. Next one is becoming 2003 like that. Like that we have a addresses for every byte has their own address. Now whenever we want to access any variable, normally we are declaring the variable in this format. So we are declaring some integer a. We are declaring in this way integer a. Now a is an integer type, so that we can get 4 byte of memory somewhere in the memory, and which occupy the 4 byte of memory. So let us consider this is a location is selected by the corresponding variable a. Let's consider this is a memory location has been selected by the a. So this is a memory is selected. How many bytes? 4 bytes. The reference of this corresponding memory is become a. The reference is a. The first byte address may be a something. The address is like a uh, something like 3000 is the address for the first byte. Next byte address will become a 3001. Next byte address will become 3002, 3001. Next byte address 3002. Next byte address will become a 3003. Like that, we have an address for every variable. Whenever we want to read the address of a particular location, normally we are using this a for various purpose. We have implemented in a something we implemented in arithmetic operation. We incremented the value, we decrement the value. We are using for different kind of purposes. Example, I have incremented the value of a. If a value is equal to 5, now 5 will be increment in this corresponding memory. This memory is a real entity. Their reference name is A. For this memory, the reference is A. Also, we have a real unsigned integer, unsigned values are there. They are referring to the a byte address. They are uh, available for the every byte 3000, 3001, 3002, 3003 like that. Now, if you want to read the address, if you want to know about the address of here, now we didn't have any practice. We no need to identify the address of any variable. Normally, we want to use the memory, and if at all, if you are exiting from the exit from the block, delete the memory. So that we had practice before this. But if you want to read the memory or identify the memory of a particular variable, use this corresponding notation. ampersand A. Now, if normally A is referred the value of the location, of the corresponding location. But whenever, if you want to read the corresponding address, we have to use this kind of notation. Address of A. Or address of A means that ampersand A is it refer the address of A. Now ampersand A is provide this notation is provide the address of a particular variable A. Now what is the address will become? Address will become a the base address will be provided. There are four addresses are there, 3000, 3001, 3002, 3003. All four bytes are allocated for memory itself because it is an integer data type which need a 4 byte of memory. Out of them, whenever you want to read the address of any variable, it's provide the base address, a first byte address of a particular variable. The first byte address is become a 3000. Okay, so the value, if the value is a 5, 5 will be print whenever you call directly A. Normally, whenever if you want to read the value from the keyboard, so what we are using scanf percentile D. If it is integer percentile D followed by we are giving address of A. What do you mean by this statement? Store a integer value in a particular address of A. We are not even accessing the address, but this notation will clear the path to identify the corresponding address of A. Now it's able to catch the 3000. Based on this address, we our key from our whatever the given input value transfer to the that corresponding corresponding location. So here already we had a practice, but we should know about what is the semantic of the corresponding notation. This notation used to find out the address of the variable. Okay, so in this address we are storing integer type values. So percentile D will refer the I didn't refer the integer value. That integer value stored at the corresponding address of A. Now this is the meaning of the scanf. We use it several times and also we write this notation several times. But actual meaning is that it is the address of a variable. Uh, this is means mm, this is nothing but it's overall process of your address. Also, we should know about one another a very important point. Can we operate the corresponding variable with address or not? With address or not? Now, whenever you call, if I print something like percentile D, comma A. What is the output will become for this statement? The statement output is become a 5. Statement output is 5. But if I use something like a printf percentile, you always addresses are unsigned integer. Unsigned integer nothing but what is your class count? 60 member. Is it minus 60 or plus 60? It's not minus 60, it is not plus 60. It is an unsigned integer, it is a 60 value. How much of money you have? I have a something 1 lakh rupees. Here 1 lakh is a number, that's it. There is no minus 1 lakh plus 1 lakh. So these kind of numbers are comes under the unsigned integer. Unsigned integer. So I am writing here unsigned integer for format specifier. The followed by the corresponding. I want to read the address so that I have given you percentile u. Of which address you want to read? Address of A. We have to mention this corresponding notation. Now which will print the 3000. 3000. Which will print the 3000. Okay. Now, if you declare something, a variable like a int c, sorry, let's declare even character variable now. How many bytes we require for a character variable? Character variable requires a 1 byte of memory. Character C. How many bytes? 1 byte of memory. So 1 byte of memory, somewhere 1 byte of memory will be allocated for this one. 1 byte, only 1 byte. So address is, let us consider 5,000 is the address. Okay. So now the memory location reference is a reference name is C. Value may be a capital A like that. You have stored here. Okay. Can we read the address of the corresponding variable? Yes, we can able to read even it is character float or double, whatever it is. Okay. By this way, you will get a address for the corresponding C variable 5,000. Then what about when you declare something in a array type? Integer, uh, some x of 3. X of 3. This is the array. Now, how many elements are there in this array? The three elements are there. X of 0 is a one element. X of 1 is one more element. X of 2 is one more element. Like that, we have a three elements. They are integer. All elements are integer. So, because array, if it is declared as an integer, then all elements are will become a similar kind of elements. Now, every element is an integer. Each element will require the 4 byte of memory. 4 byte of memory for every element. So, like that we need a total 12 bytes of memory. 4 bytes 4 bytes. Total, we require how many bytes? We require 12 bytes of memory. Somewhere we have some 12 bytes. Let us consider and drawing a 12 byte of memory. Somewhere in the RAM or cache memory, we have a 12 byte of memory. So because we want to store it in a continuous location. So 3, 4, 5, 6, 7, 12, 13, 14, like that. Here we have a very huge free space. We need only 12. We need only 12 so that the corresponding variable is occupying from here. So first byte, this is the first byte, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, 11, 12, up to 12. So they are starting from here. It is starting from here. So this 12 bit of memory occupied by the corresponding array. Now, how many bytes occupied by the each element? 4 bytes. One, two, three, four. So these 4 bytes for first element. One, two, three, four. Second 4 byte. Okay, third 4 byte. One, two, three, four. Here up to this is the end. Okay. So there are total three elements are there. Each element occupy the one 4 byte of memory. So that we can say it is a zero index element. Now we can write it as x of zero. So the next one is this is a one index. Now generally we are writing it is a x of one. Okay. Similarly, next index value is become a two. Now how we are writing how to access the value of this corresponding to index x of two. Here, this is zero index, this is one index, this is two index. Index are they are a reference number to access the particular element from the array. Actual numbers, actual byte of memory, let us consider it starting from 3000 is the starting byte address. Okay. Now next will become a 31, 3001, 3002, and 3003. 3003. Next byte will become a 3004. It will become a 3004. Next value will become a 3005. Next value is become a 3005, 6, and 7. Next it is become a 3008. Like that, every element has their own starting byte address. Every element. For this element, starting byte address is become a 3000. For this element, starting byte address 3004. No, for this element, starting byte address will become a 3008. For entire array, what is the starting address? 3000 only. For entire array, if you want to identify the address, it provide the base address and our first byte address. It is become 3000. So now I want to write something like if address of something like a x of 0, what you will get? You will get 3000. You will get 3000. Now I want to take the address of first element. Now the answer is become 3004 address. A similar way, address of x of 2, you will get 3008 like that. But if you want to read the address of the x, address of x, give a name of the array, the base address will become a 3000. For entire array, the first address is become a 3000. So like that, normally we can able to understand the memory structure in a easy way with this corresponding address notation. Every address, a RAM, a cache memory, even the register, they are normally evaluated with a byte-oriented memory. So each byte has their own address. Now, whenever you want to extract the address of a particular location, so according to the variables may occupy the 4 byte, 8 byte, whatever they are, but first byte address will be provided. Okay, for array we can individually access the address of each and every element. Also, we can access the base address of a array by using array name. Now, this first we should clear about this concept. What do you mean by the address? How they are in the memory. So let us go to the pointers now. After you understanding clearly about this, you can easily catch the concept of a pointer concept. Now, I already said that key variable store in a particular memory location. And they occupy if it is an integer type, it occupy the 4 byte of memory. Each byte has their own address. But whenever you read the address of some particular area which provide the first byte address, that may be a 3000 or 2000 something will provide the first byte address, whatever it is, that will be provided. Now this time we want to store we want to declare a one variable. The variable name is a pointer, and that variable can only store the address instead of the value. Instead of the value of values, it store only the addresses. Then such kind of variable names are called as a pointer. We will discuss why we are using this pointer variable. First, let me declare, and then after, let me process with one variable. After that, I will clarify your doubt. What is the major purpose of a pointer? First, let's declare some variable. There is a one variable A. Now, A is an integer type. A is an integer type. It has their own address. That address I want to store in a one pointer variable. If you want to store in a one pointer variable, then you should also declare the pointer variable with same type. With same type we had to declare same type. What is the type? Integer type. If anyone is delivering a product for a Amazon, he should carry the address of Amazon customers only and delivering a particular address with Amazon product, not with a Swiggy, Zomato, or Flipkart. So their delivery boys should carry their relative customer addresses only. They should not mismap the delivery product with a different kind of addresses. So in similar way, if anything you want to store the address of an integer variable, then we have to declare the variable in the same time. First, it is a declaration. Now, why we are declaring this? This is called as a pointer variable. Now, what is the actual the pointer variable do? Pointer variable, pointer variable for the address of a same time variable, same data type variable. Data. This is very important. Data type variable, rather the value means instead of the value, it cannot store the values. Never the pointer variable store the value. It store only addresses. Store only addresses. Then that is a property of a pointer variable. So now, how this variable will store the address? Remember, the definition is a pointer variable store the address of same data type variable. Okay, this is also very important point. We cannot store the address of float type into integer. We cannot store address of character type into the integer pointer. If you want to store a character type variable, then we have to assign a one more pointer that should be declared under a character type. So same data type is very important. Then what we are discussing now, pointer variables for the address of the same data type rather than the value. Now, how how it is going to be stored? Now, the following after this, the next statement is become now p is equals to we want to provide the address of a variable to a variable or to a pointer variable. Now, pointer variable p will assign with address of a. If I write something like a address of a, will this p will get address? No, it is a sentence. We should provide the address of any variable by using a notation format. That notation format is become an address of A. Address of A. Now see, this is providing this address of A means what do you mean by the address of A? According to our previous slide discussion, we know that address of A is a 2000. Now 2000 address transferred to the P variable. Now what is a P value? P value is the address. The value address. What is the address by address? 2000. Like that we are assigning. So this is a second line after you declare. Now how this could be happen? There is a one variable, actual variable, our a variable you have declared. Now the variable a variable actually occupied in a 4 byte of memory, 4 bytes. In that 4 byte, the first byte address is there something like a 2000. It's the first byte address. I'm not talking about the remaining byte address. It's the base address. The name of the variable is a. Name of the variable is a. Now we didn't assign any value. We didn't given the name for that. Then after we are executing this statement. What is this statement? This statement is assigning this address to pointer variable. So there is a one more variable like pointer. There is a pointer variable. Now this pointer variable assigned with a one value. The value is something address of a. Address of a. Name of this variable is a p. Name of the variable is a p. It is also integer variable. It is also stored in a memory itself. It also has address. Address is a 5,000 example. It is a 5,000 address. It has their own address because it is also variable. Now I am running an office. There are 10 employees are there. 10 employees are coming to my office. But office means it is also a house. It is also some constructed structure. 10 people are coming from their home. They have they have their own houses and structures. Now office means it is also one structure. It should need some rooms, walls, pillars, everything we need. Office means it is not a virtual process. It's a physically structure is there. In that structure, the 10 people is coming, 10 people are coming and they are doing their job. Okay, themselves they have their own houses. Similar way, there is one pointer. The pointer also a variable, which also need one address. Yes, there is an address for it. My office also need one address like that. Your home also need one address, but your address is I'm putting in my record. That's it. So this is the thing. This is the thing. P pointer variable cannot store the value. Cannot store the value, which means it is now pointing to the variable A. Now whatever you are applying on A, now if I apply some arithmetic operation, this we can do from pointer also. If you are applying some operation on P, now that automatically directly click on A. If you increment P, now here the value will be increment. If you decrement P, now the value of A will be decrement. Now what happened here? On a single value, we are controlling with variable and pointer on a single memory. Single memory nothing but this is a single memory. On this memory, we are applying some control on direct variable as well as now we are controlling with pointer also. Now this memory we could control with pointer variable and also a. So let's see what the exam with the example you will understand. Now I want to read the value to read the value. What is the format percentile D, comma, address of A. So after you know about the concept of the address of A, why we should write address of A here? What do you mean by the address of A? Address of A already there at P. Already there at P. Why don't we give P? Yes, we can give a P here. Address of P is equals to both are same. Address of whenever you print address of A, you will get address. Whenever you print P also, you will get 2000. Now, instead of the address of A, we can write, sorry, address of A, we can write P directly. Now, P also address. Okay. So there are two things I have done. First, I had declared the pointer variable, then I assigned pointer variable with address. Then next, I want to print the value of A, some printer, something value you have given, like 5 value you have given. Now, percentile D, comma A. What will be the output? 5 value. If your input value is a 5, then output is become 5. If the value of A is a 5, then what is the output of this statement? 5. Then printf. I want to know about the address of A. As you can know, you will get understand. So uh, you want to print the address. Whenever you want to print the address, better use the constant integer. Now, how to write the address of A notation? Address of A, simply we had to practice several times in scanf. Same that notation we should give. You will get address of A. What is the address of A? 2000 is the address of A. Now I want to print F. Same address. I can also read from. I can also print from P variable. Yes, same percentile U. Percentile U, comma, address of. No address. No, it's P. Semicolon. You will get 2000. Okay. So this is about generally printing of address from normal address notation format and by using pointer variable. Next, I want to print a value. Already you print a value by using a. We can also print the value by using pointer variable. How to print a value? How to print it? By using indirection operator. Indirection operator, that means a pointer operator. The you have to give that pointer followed by p. So this notation print the value. This notation print the value. So now you clearly should understand here P is equal to address of A. Now P means 2000, address of A also 2000. Both are same. You can call with P, you will get address 2000. If you call ampersand A, you will get 2000. Now, whenever you print something A, you will get value. The same value we can able to print in this corresponding address. Now I am applying on this pointer variable, I am applying indirection operator. What actually this operator will do? This operator first will reach to the pointer variable and will read corresponding address, will read this corresponding address and will cache the value in this address location. Control travel no, cache the value from this address location. It read the address. What is the address of in my p variable? If there is a 2000 address, okay, immediately we should travel to the which goes to the corresponding 2000 location, and from here we retrieve the value. So that is the use of this indirection operator. If you don't mention this operator, you will get only address. If you don't mention this operator, you will get only address. If you mention this operator, you will get value at that location, value at that 2000 location. So that is the difference. So we can able to print the value by using this pointer variable. Now we can also apply various kind of arithmetic operations. So let's apply one arithmetic operation. I want to apply. If you apply a plus plus, what could be happen? After that, I want to print. After that, I want to print a. So your answer will become a 6. A is 5. You have incremented it. Now your answer will become a 6. Similarly, we can able to apply any kind of operation on pointer variable. Now, what is this variable? Pointer variable. On this pointer variable, I want to apply plus plus operator. I want to increment this operation. Pointer variable increment. What could be happen? Already you know about point normal p is a 2000. Pointer p nothing but value. Pointer p nothing but value. How could I get the value? This operator first to read the address. Based on this address, control transfer to the location and retrieve the value. So pointer p nothing but value. On this value we are incrementing. So already 6 it will become 7. So that on that value it is incrementing. If I give a p plus plus, what could be happen? What could be happen? If you give a p plus plus, which increment the address, What is the address of a? What is the address of a? Address of a is a 2000. Means it is not only 2000, there is a 2001 is there. Not only 2000, normally it is printing the 2000, but there are 4 bytes are there. 2001 address, 2002 address. How many bytes? 12, 4 bytes. 2003 address. Now what do you mean by the P plus plus? Which increment the one variable memory address. Complete which increment the one variable address. Means after 2000, if you reach the 2001, again it is become A itself. If you reach to the 2002, again it is A itself. If you reach to 2003, again it is become A itself. Where you can find a new variable after 2003. So that P plus plus which print the address of 2004 address, which increment with one variable memory space. Increment on variable memory space. If the what is the integer variable memory space? 4 byte. If you apply increment with pointer variable, which increment the variable space, variable total space is 4 bytes. So initial value 2000. So after you are incrementing, your value will become a 2004, not 2001, 2, 3, because these three addresses also belongs to A itself. A itself. Okay, in such a way, pointer will be operated. You will clearly understand the pointer with array. Okay, we can also apply some kind of arithmetic operation. Now I want to apply something like some there is some variable c. Now c is equal to pointer p plus pointer p means there is a value pointer p plus 5 c is equal to, or else I want to store p pointer p not using a. You can use a and also you can use the pointer p where both are operating on same memory now. This statement also can able to write with some a is equals to a plus 5. Both are same. Both are same. But we are not using here variable. Here we want to do the same kind of operation by using pointer variable. Now what is the answer will become? Now p will get updated with the corresponding variable. Corresponding variable updated. What is the last modified value of 57? Now it is become a 7 plus 5, 13. It is become 13. Okay. Now, if you print A, if I print A, if I print percentage D, comma A, the answer will become 13. Answer will become 13. Actually, this operation is not applied on A. You are applied on a pointer variable. Whenever you do some modification on pointer variable, that directly reflect on variable A itself because it has only address. Whenever you are call pointer P, which will reach to the your memory location, your A memory location, and apply the changes on A memory value, not on this address. This is only the address. Like that, the same memory can able to operate with two variables. One is a pointer variable, one is a normal variable. So like that we are operating. But what is the benefit of the pointer? Pointers are very fast accessing memory, make the access very fast, comparatively normal variable. That I will explain in the next video, how they are speed of the point execution process in a computer or compiler.